Yeah, okay, let's get started. Hello, everybody. So, I mean, obviously it's different timing of the day for the folks here. So, welcome to the Chaos Mesh meeting of the October. I'm Kelvin. So, I'm one of the Chaos Mesh maintainers. I'm focusing on the community operations. So, I'm really glad to be your host today. So before anything else, thanks so much for joining this meeting. Yeah, we have many old friends here and also some new faces here. Nice. So we're really flattered, and regularly we will have one by one self introduction, but today we have 1 hour sharing, so many attendees. So instead of these introductions one by one basis, I would like to invite you to update the personal info under this attendee section, and you can add as much detail as you want to. So, and also a kindly reminder here, so please mute your microphone if you're not speaking. And also this meeting is recorded and the video will be uploaded to YouTube after the meeting. Okay, as we mentioned earlier, this is a special meeting because we have a special guest here. So let's welcome Jonathan Johnson.
Hey.
Hi, Jonathan. Thanks so much for coming. And
thanks so much.
I know, yeah, it's so late for you because obviously you're in the opposite.
That's okay.
Hours.
That's all right. Actually, you pulled me away from the U.S. Presidential debate is happening right now, so thank you for pulling me away from that.
How is that going?
I'd rather talk about chaos rather than. Let's put it that way.
That's kind of okay. That's kind of chaos too.
This is a better chaos.
Okay. In case you do not, know much about Jonathan is a independent consulting professional with many years of expertise in the software industry. He's also a public speaker and doing a lot of workshops focusing on various cutting-edge domains such as software architect, Kubernetes, and Java. So actually, this sharing in this meeting, Jonathan is generous enough to squeeze a 3-hour workshop into this session. So yeah.
Great.
Yeah. Thanks for that. Yeah. So thanks, okay. Yeah. Our agenda is pretty simple here because we do not have time for the regular community updates. We will jump directly into our sharing session, which is the Kubernetes Chaos, as you can see. And also after the session, we will have like 5 to 10 minutes of Q&A session. If you have any questions, you can also you can ask directly, or you can write your questions here in advance. Okay, without further ado, let's welcome Jonathan to give his sharing. Just so you can start sharing your desktop. Let me stop sharing now.
All right. All right. Well, thank you, everybody. Thanks for inviting me. Yeah, I think I came on your radar because I started writing a Katacoda scenario related to Chaos Mesh. In fact, I did one for a couple different Chaos open source projects. And I was contacted by your group, and I said, "Hey, let me show you what I've been doing, and you've actually worked with me and helped me validate the scenarios." It's pretty good. Let's see. We get started. My background is about 30 years of software engineering, release management, and delivering applications to for various types of industries and companies. I got involved in Kubernetes, I don't know, 4 or 5 years ago, 4 years ago, 4 years ago, about that. And I've been, since then, in the last, about year and a half, I went full time in terms of being independent as a consultant. I'm an independent software architect, and I'm diving in the world and swimming in the world of cloud native computing, microservices, containers, and particularly Kubernetes. And of course, everything that's in the Kubernetes community, everything's that's in the CNCF community. Nothing is out of my realm of what I'd love to talk about, because there's so much going on in the industry. Chaos is being one of those things. Chaos engineering is a huge thing in the whole idea about cloud native computing. So definitely want to be covering a lot of those topics, and it's growing in my repertoire, in my portfolio of things I consult about and talk about. I've looked at some other projects, and I've looked at Chaos Mesh. I've been really impressed by, just in a year, how much traction and growth you've done in the project. So definitely found, I said, hey, this is one of the scenarios I want to teach about and talk about. And I want to share that with you today. I'm going to take you through some very light slides. Honestly, this is a introductory talk to just chaos engineering. Just gives you an introduction to Kubernetes with chaos. But I'm developing this into a workshop. This is kind of like an early form of the workshop. So let me take you into some slides. But most of the time, we're going to be walking through some scenarios, hands-on scenarios, that you also can run by yourself. And then we will, I'll run 2 scenarios just to give 2 different types of examples of chaos and Kubernetes. And then I'm going to be opening myself up to any kind of questions you have. And of course, I have a lot of questions about the Chaos Mesh project as well. So maybe we can have more of a conversation rather than just questions to me. I'll be back and forth. So feel free to ask questions in the chat window. You can even, don't be shy. You can turn on your microphone if you want to ask me directly. I'm here. You can even turn on your camera. We're all friends here. And I'm very comfortable with you interrupting me, or if you have questions, I'd be happy to talk to you. Okay, so let me dive into just a few slides, and then we're going to dive into the scenarios. The slides are, just bear with me, right here. So I'm just superimposing myself on top of it. So I'm going to talk about testing patterns in a sense of, on Kubernetes, there's the idea of testing everywhere and across all the different phases of development and distribution and production. Then I'll briefly mention the idea of consumer-driven contracts, which is another form of testing. And then we're going to dive right into chaos, and we'll dive into some of the other projects and things related to chaos engineering and Kubernetes. So for testing patterns, the idea of maturity model within organizations. So this is one of the things I see that's coming. The Chaos Mesh project is positioned itself in the right time and space related to what's going on in the industry. People are moving from a very immature maturity model about how to deal with distributed computing and Kubernetes, and they're moving up the stack of higher levels of maturity. So then one of the notions about when you start going into things like cloud computing on Kubernetes, on cloud systems such as EKS or AKS or GKS, you need to have a higher level of maturity within your organization. As an example, you need to do better CI/CD. You need to have continuous integration, continuous delivery, even before you start diving into Kubernetes. You have to understand containers. You have to understand architectural patterns, such as microservices. These are all prerequisites and things you need to accomplish before you can start diving into, okay, let's do Kubernetes. You also have to divide up your team into, maybe people talk about the Melvin Conway law. You need to think about how you want to organize your teams so you can support an architecture that's not monolithic but distributed. So there's this whole idea of like being tall enough to ride that roller coaster, and it always reminds me of that, sorry, a little loud here, but it's that roller coaster. One of the roller coasters we went on. It's in Orlando in Florida in the U.S. And this roller coaster it's kind of like chaos, right? It zips you out of this tunnel at about 60 miles an hour, and you're zooming along. So, but in order to ride this roller coaster, in many ways, this is a cluster. This is a Kubernetes cluster. In order to ride this, you need to be tall enough to ride that roller coaster. And I actually went on that roller coaster with one of my children, and two of my children, one of them was not tall enough for that ride, and one of them was. And boy, that created a lot of problems. I like this maturity model. It comes from Armory, the makers of Spinnaker. And I like what they put together. So I want to reuse their slide. I want to reuse their infographic on it. And if many people will look at their organization and they'll say, yeah, we're very mature. We have a lot of processes in place. Yeah, we're using Jenkins. We're building all the time. But then they look at a chart like this and say, you know what? Yeah, I guess they think they're at level 4, maybe even 5, but it's the very humbling chart where they'll look at a lot of these stages and say, yeah, we're not quite ready for this yet. So my point is, if you look at stage 5, which is the most mature stage, and if you look at that particular area, you'll notice that one of the bullets that they have there is chaos engineering. So if you have mastered chaos engineering, that's one of the check items for being at stage 5 in terms of the maturity model. The closer you are, the idea behind this is that the closer you are to stage 5, the more ready you are to be successful with a complicated system such as Kubernetes. And if you've embraced chaos engineering, that's one of those things that help you guarantee your success, or at least make you more successful. It may not necessarily guarantee your success, but it will get you in a better place. And I think most people haven't addressed this yet in their organizations. They don't quite understand, the value or the benefits of it. They may have looked at some experimental or some example codes of like, oh, I want to just kill a pod. And they think, oh, that's cute, but how would I actually use that? But I think Chaos Mesh and others like Litmus are you're all positioning yourselves in a situation where eventually many of the enterprises are going to be coming to you and saying, yeah, we've heard about this Chaos Mesh stuff, and I think we need to start really taking this seriously. What do you got? So you're on the right time for developing Chaos Mesh and get it ready for when those those enterprise people start coming to you. Right now, what they're doing is they're going through a lot of the transition of adopting Kubernetes and thinking about how to use it. But there's also going to be this trough of disillusionment where they're thinking, oh, this is actually kind of hard, and we need to do more with it. And consultants like Armory come to these companies and say, look, this is your maturity model, and these are the things you need to go to, and yours is one of those check items. Okay. So another proponent and another example I wanted to show you about the importance of chaos engineering. I really like Cindy Sridhar's book, Distributed Systems Observability, logging, tracing, metrics, looking at the performance of your system at runtime. And I like that book on it and what she talks about. In fact, she has a chart. Another infographic that I'm going to steal as well. Not steal, I'm going to share with you. So this is her graphic. And she's talking about day 1, day 2. Day 1 is when you're building your applications and you're building and putting them together. That's day 1. Day 2 is, okay, you've deployed your applications out, testing or in production or some form of beta testing. And you've got to do testing there. She's basically listing out testing should be part of the entire life cycle of your development system. From early development, a lot of people talk about like test-driven development. That's really important. Well, it is really important, but it's only one of the important types of testing. that happens, and it's all during day one production. But there's certainly testing and observability that you should be doing at day two in production. And two of the ones that she talks about, or she mentions in this list, are two that I have honed in on in terms of my talks and my talk about. One of them is called contract testing. It's called consumer-driven contracts. And I actually have a whole workshop and presentation I do on that. I'm not going to do that tonight, but I just wanted to mention to you that besides chaos testing, another type of testing that I'm interested in is consumer-driven contract testing. But the other one, if you look at Cindy's chart, infographic, you'll see on the right-hand side, she's got also mentioned chaos testing too. Again, to back up the evidence of this is really important. We all know this is important. I'm preaching to the choir. I realize that a lot of you that are attending tonight are chaos mesh, advocates and understand the need for it. But I also just wanted to pull out the fact that chaos engineering is important. And I believe that as more people start diving into the needs of day two operations, they're going to start looking at chaos engineering and are becoming to projects like Chaos Mesh to find solutions for, at least for Kubernetes. And I do a lot of talking about Kubernetes. So like I said, I do a lot of talking about Kubernetes and I do a lot of different types of talks. I'm not going to walk you through this, but this is my talk on consumer-driven contracts. And I walk people through testing patterns. I walk them through the concepts of what a consumer-driven contracts are. And then I walk through the ideas of, there's an implementation that's been around for several years called PAC testing, P-A-C-T. And then I walk them through some Katacoda scenarios, online hands-on scenarios that will take you through those. They're published already, and if you're curious to run those Katacoda scenarios, you can certainly do that. Afterwards, I will put in the URL for you to run that scenario to teach you about PAC testing. But I also do some talks on this, and I'll give you some URLs about next month. I'm going to be talking about not just chaos, but I'll also be talking about consumer-driven contracts in a workshop, and I'll give you that URL for that. But let's move on to chaos. And then we're down to the slides, and we'll get right into the hands-on. All right. So many of my talks, I did a 3-hour workshop today for O'Reilly. So in that workshop, I said, in my introduction to Kubernetes, I also talk about Kubernetes. I talk about Kubernetes as being two different things. One, Kubernetes is an operating system for the data center. You have a distributed cluster of nodes that's distributed over a network, and Kubernetes acts as a operating system that will manage CPU, memory, and I/O across all of those machines. It's a fairly strong and broad statement, but I'm going to leave it at that because that gets into a whole other talk about what Kubernetes is all about. But the other thing I want to mention is that Kubernetes is a state machine. And a state machine is the idea of, it's an engineering principle. It's nothing unique to computer science. It's an engineering discipline. So a state machine is something that maintains its state. It often has things, there's control mechanisms in there in a state machine to maintain a particular state. Inside of a state machine are also mechanisms that do observability or measurements of the state. And there's a constant loop that's looking at what is reality versus what's the declared state. So in Kubernetes, we have these things called control loops, reconciliation loops, and there's controllers that are running. So when you as a developer make a declaration to Kubernetes saying, I want 100 microservices, it will run 100 microservices of whatever pod and containers you have. And it's going to maintain that. And if you say these microservices should be able to connect to these services and these services cannot connect to these services, that's all declared state about how your topology of your distributed system should work. Kubernetes maintains that. And if you go over to Kubernetes and you actually stick it, like this fellow is doing at, what is it? Sorry, I always forget the name. Boston Dynamics. So Boston Dynamics is the company that's building a lot of these advanced robots. So they have lots of videos online if you haven't seen them, where you can poke, where they're poking these robots to see, because robots are state machines. Like a Kubernetes cluster, a robot is a state machine, and it's maintaining a state. In this case, it's standing up, and it's trying to maintain a balance. And this engineer is poking it with a hockey stick to see what would happen as an experiment, to see what would happen if you poke that robot, and what would happen. Will the robot fall down, or will it just teeter? And if it does fall down, does it have the ability to get back up and go back up to its declared state? Its declared state is to stand and stay balanced. And so that hockey stick is chaos. That's chaos engineering in a physical manifest. You're doing the same thing with Chaos Mesh. You're just happy to do it through software, but it's the same engineering principles. It's the same physics that's going on. Okay? So if you fear walking up to this robot with a hockey stick, and you say, oh yeah, don't do that, it'll break the robot. If you have a Kubernetes cluster where you fear being any kind of a chaotic disturbance, then you probably don't have a very resilient cluster for production. In fact, when you do poke a robot or you do poke Kubernetes, you should do it in production with a limited blast radius, with a limited disruption. But you should do that testing in production, because that's the most realistic place to do that type of testing, is when it's in production. So I love this video. When I was in college, I was dating myself a little bit. When I was in college, I loved animation. I still love animation movies. And there was an animation film festival. And I saw this video, and if I can just engage with you just for a moment. This is from Wolfgang Luschenstein and his brother, Christoph. And they made this award-winning video, animation. It was stop animation, clay animation. And it's another visualization through art of state machines, of balance. And you can imagine these as being microservices running on a Kubernetes cluster. The slate underneath is the slab of balance. And throughout this, I'm not going to show you the whole video. I would encourage you to run it. And during the Q&A session, I'll grab that video URL and put it in the link for you. But I just wanted to let you know that this is a great video to show to somebody what chaos is all about, right? So you have these microservices that are on this slate. That slate is the Kubernetes cluster, and it's balanced. And as these microservices start doing whatever they do on that cluster, things start going chaotic in production, to the point of, let's see if I can do it. I'm trying to get my cursor here. Hold on. I've lost my cursor. There it is. All right. I'm going to fast forward in the video a little bit, just a spoiler alert here. But they start messing with the cluster. There's a box that gets introduced into the cluster, a new set of data, and things start going out of balance, and they start manipulating themselves to maintain that equilibrium of it. And eventually, some of these microservices, some of these characters fall off the cluster, which happens in Kubernetes. Some pods will go away. But even if they do, there has to be some time of maintenance of balance. So I would encourage you to go off and dive into that. It's only like an 8-minute video, but it's really a wonderful thought thinker. And it's a great thing to share with your friends who are also chaos enthusiasts. So chaos engineering and the idea of chaos all starts with the idea of a scientific method. It's the idea of proposing a test, saying, what if in other words, what if I take this hockey stick and jam it into that robot? And I do it with 5 pounds of force, I'm putting a number to it. That's the propose, that's the question. And then you have a hypothesis. You say, well, if I do 5 pounds of force, it will probably teeter. If I do 20 pounds of force, it might fall over. But in both cases, my hypothesis is that the robot will stand back up. If I kill 80 of my 100 microservices on Kubernetes, I propose that my customers will probably see a latency, but will still be able to satisfy the service level agreement of 5 nines, even though they might experience some latency. And I know that after a few minutes, those 80 microservices will be restarted and the system will be back in equilibrium. So that's an experiment. And that's exactly what you want to be doing with all these chaos projects, is you want to be able to think about a question, formulate the question into an experiment, run the experiment, and then observe the experiment through observability, logging, tracing, and metrics, and then come to some conclusion. If you poke that system and you find out that whatever you poked at, whatever your experiment is, didn't work out the way you wanted it to, that's a great thing, because now you've realized that what you thought was reality of how the system is going to be resilient is not. And that's what you're getting after. You're getting after I expect when I do this, it will be resilient this way. And if that experiment doesn't work out, there's a teaching moment for you. This is why we do experiments, to find out. And the more experiments you do, in other words, testing you do, of chaos testing, the more you're going to feel confident about your system in production. You know that if you tweak that robot, it's going to stand back up. But if you're doing things like, especially if you're experimenting with things in production, you don't want to go to your CTO or CIO or your executive and say, hey, guess what? I'm running some tests in production, and yeah, it might disturb some of the customers. They're like, yeah, no, you're not doing that in production. In fact, that's you be able to touch production from a developer. I say, I want to run an experiment. I want to try it in production. That will not fly in a lot of organizations. And that's part of the maturity model for organizations, to understand the need for running these types of experiments actually in production. And if the C-levels or the technical leaders understand the need for that, you're at a higher maturity model with your organization. If they don't understand that, then you've got more work to do in terms of getting to that stage 5 and accepting chaos engineering. Now, you don't have to do chaos engineering in production. You could be doing it in test systems, of course, and you could be doing it locally on your local laptop as well. You can do chaos at any stage. But where it really pays off is when it's in production and you can trust that production environment. So you want to limit your blast radius. So when you try these experiments, it's only disrupting a few services. In other words, you might blow away a few of the services, but most of the services are still running, and you can, in the background, observe the fact that, okay, I lost 10% of the services, and I see that they didn't restart that gracefully, and I want to learn from that experience of them not restarting gracefully. Or I want to inject a little bit of latency into the network traffic and watch. But only for the users that are logged in as beta. So that's a blast radius. Only controlling who actually experiences the latency or the downtime or whatever kind of chaos that you're inflicting on the system. Not on your users, but on the system. Because in most cases, you should be able to run these experiments, and most people would never know that the experiment is actually running if you design the experiment correctly. And that's the trick. And the part of that trick is observability. You need to have, so before you can do chaos engineering, you have to have under your belt good observability, right? So you can add something like Prometheus, or go to a commercial vendor, Datadog, or there's a bunch of them out there that can help you out with observability on Kubernetes. So observability is really important before you start experimenting, because if you can't observe your experiment, you're you're not going about it the right way. There's some prerequisites before you can start doing chaos engineering. So definitely observability. And you definitely want to have those conversations about not only do I want to start doing chaos engineering, but I actually need to do it in production, which scares a lot of people. And that has to they have to have that conversation. So Cloud Native Computing Foundation has a tile of a few projects, and Chaos Mesh is one of them. Chaos Cube, Chaos Toolkit, Chaos Blade. There's Gremlin. I'm sorry, I like Gremlin the best just because they have the best logo. No, I'm jesting, but they do have a really good logo. I love the idea of like gremlins. And Litmus as well. So I have Katacoda scenarios for Chaos Mesh, Litmus, and Chaos Cube as a few, and a few others that are minor that are not on this list. And they shouldn't be on this list, but that's okay. So I'm going to take you through a couple scenarios at the end of these slides. So it's interesting when you go to Chaos Mesh and you look at the website and you go through the documentation, you say, oh, what kind of experiments can I run? And the project lists out these experiments. Maybe there's a few more since I created this slide. I know the project is growing very rapidly in the last year. And I'm sure there's a few more maybe in the works about other types of experiments that people can run. But the most common one, the hello world for Chaos Cube, especially on Kubernetes, is to kill a process. And in Kubernetes, it would be to kill a node. Not to kill a mockingbird, but to kill a node. But there's also pod fail. In other words, don't kill the pod, but actually disrupt it so it fails. Killing containers within the pods. Pods can run multiple containers. So what would happen if you kill one of the containers inside there? And then you get into network communication, disrupting the network. There's also, you get into things like disrupting the available CPU and disrupting the available memory. And then you start getting into file I/O. So these are all resources they're resources of the operating system. Like I said early on, Kubernetes is an operating system that's managing CPU, memory, and I/O. And you want to test how well your application works when suddenly those resources are not as available as you might think they might be. Often when I talk about Kubernetes, as soon as you go from a monolith and then you go and package your application into microservices and put them in containers and make that decision, that turning point in your career to say, I'm going to run part of my application on this server and the other part's going to work on this server, and they're going to communicate to each other over a network. You've now entered the idea of distributed computing. And there are 8 fallacies. I don't have a slide for it, but there are 8 fallacies of distributed computing. And some of them are, your topology is never consistent. Your network is not consistent. The latency will always be there and will rear its ugly head. In other words, there's always going to be entropy within your system, and with entropy you have chaos. And that's going to happen, especially when you start adding more things to your cluster and you start throwing off that balance of that slab. You're going to have more stress on the system. And anytime you have more stress on an engineering system, you might incur imbalance. And the fallacies, the 8 fallacies of distributed computing are basically saying it's not a matter of if things happen, it's a matter of when. And Kubernetes embraces the fact that things are going to fail. So there's experiments that you can design based upon these to do different types of what if scenarios. So instead of waiting for those bad events to happen, you can create experiments that will essentially simulate a network latency or a network disconnection or a complete node in their cluster has gone offline or simply a pod or a group of pods have gone offline. Those are all the experiments you want to experiment with. And you don't want to wait for them to actually happen in production. You want to experiment with them in production to have confidence that your robot will stand back up. Now, other projects, Gremlin has the same kind of idea, same kind of experiment design. Litmus has almost the exact type of list. In fact, from an end user developer, from an architect standpoint, I'm kind of looking at all these folks, all you folks, and saying, you're all inventing the same wheels here. Why don't you work together and maybe make and combine efforts? Maybe that's happening in the scenes behind. I don't know what the politics between all these open source groups are, but I do want to say that you're going after the same ideas on Kubernetes. Disfill, disloss, and it's a cat and mouse game. It's almost like browser wars, where you're looking at what other people are doing, and you're creating more avenues for me to experiment with on a Kubernetes cluster, which I love. It also says that there's nothing that says, as an architect, that there's nothing that says I must use only one and only one of these. In fact, a good architect and a good tester uses lots of tools. They pull lots of tools out of their toolbox. So there's nothing that says you couldn't run Chaos Mesh as well as Litmus, as well as Gremlin on the same cluster, or some on this cluster, different ones on a different cluster. You can mix and match them because some of them might do one experiment better than the other one. So pick your tool, pick your experiments, and then pick your tool based upon the experiment, rather than pick your tool and then live with the experiments that they force on you. I would say pick the experiments first, design first, and then figure out what tool runs that experiment the best. Okay. I have these, so now that's the end of my slides, almost. Then we're gonna get into these Katacoda scenarios. I could show everyone this evening, every scenario. I'm about 40 minutes into it, about 20 minutes left. But I want to show you pure chaos, which is doing chaos from a pure software standpoint. We're going to build, using Python, we're going to build a small container that runs chaos. And we're going to deploy it onto a cluster, and we're going to watch it run amok. And it's just going to kill some pods. There's another fellow created something called Cube Invaders, which is literally, I love it because it's very, I love it because it's fun. And it's not a serious project. You would never use it in a real system, but it's a great way to learn chaos. And what he did is he actually did a pod killer, and he put Space Invaders, the old arcade game, and you can play in Space Invaders, and when you kill one of the aliens, it's killing a pod in the cluster. And then you quickly see the aliens like reconstruct themselves in the view. Run that Katacoda scenario. It's a lot of fun. Show it to your friends. There's KubeMonkey, which is so KubeMonkey and Chaos Cube, nothing against them, but they started the projects and they do pod killing, and that's it. At least that's all I saw in the documentation. They didn't get into the experiment designs. So I look at Chaos Mesh and Litmus and Gremlin, and maybe a few of the others on the cloud native tiles as being more mature than, nothing against, I don't mean mature like you're immature. I just mean those groups need to do more to those open source projects to get to the level to be able to do this type of thought experiments, running these, creating these experiments by not just looking at killing pods, but doing more than that. So, but I did create some Katacoda scenarios to take you through those open source projects. But I really look at Chaos Mesh and also Litmus as being another one. I'm sorry, I'm not showing actually Litmus on this list. It should be on this list. I'm missing that. So let me just take you to that list. That list is right here. And I will share with you the Katacoda link. Now I'll describe to you what Katacoda is too. I realize I haven't done that yet. So here's a switch over to my browser. And all these scenarios just run in the browser. And Katacoda was purchased, it was created by a fellow by the name of Ben Hall. He lives in the UK, and he created Katacoda. And about a year ago, O'Reilly Media bought Katacoda. So now it's an O'Reilly product. You can run Katacoda scenarios. You don't have to be a subscriber of the O'Reilly learning platform. They do have Katacoda scenarios inside their platform, but there's also public ones. And I make sure that when I create scenarios, they're both public and private on both sides of the fence. So these are my Katacoda examples, and there's other folks that have created other Katacoda scenarios. These are little vignettes, little teaching moments where you can go in for 10 or 20 minutes or half an hour and learn something. Every one of these scenarios is a teaching moment. And two of the things that we're going to do, we're going to dive into one course I have right here called Kubernetes Chaos. And by the way, here's my link to my scenarios. I have about 50, and I have 2,000. And next year, I'll be probably creating another 100 to 200 scenarios. So there's Kubernetes Chaos right there. So we're going to go into that course. And in there, see, I also have litmus on this list as well, which I didn't show you in my slides. And we're going to go into what we did for Chaos Mesh and show you that running in Katacoda. But the first I want to do is just show you pure chaos, which is no open source framework. Just how do I use the Kubernetes API to design an experiment? And I just want to design my experiment in code, in Python, right? Which is like how all these projects got started, was somebody came along and said, hey, you know what? Let me just experiment with writing some chaos in code, Python or Go or Java, whatever code you want to write it in, or language you want to write it in. And let me go against the Kubernetes API to manipulate Kubernetes to do things like, of course, the hello world is Kilopod. So we're going to do the hello world Kilopod with Python. Python is going to be, the scenario is just starting up right now. Python is going to be calling the Kubernetes API, which will access the pods in a namespace and then kill those pods. It's taking a little while to start up. I'm hoping it will start. So there it's started up. So on the left-hand side, we have Markdown about what the cluster, what the scenario is all about. And we're on step 1 of 5 right now. So we're going to walk through all 5 steps. On the right-hand side, we have a bash shell terminal. So if I say uname-a, I know that I have a Linux system here. It's a live Linux system. These are very ephemeral boxes that you're running. These are virtual. It's all free, by the way. No credit card. You just can't do Bitcoin mining on it or anything like that. These scenarios are around for about an hour. If you get kicked out of them, you just have to start the scenario again. There's no persistence to them. So they're very lightweight, and they're great sandboxes for you to play in, but you can't save things. It's not a persistent type of sandbox. But right now, what we have is a Kubernetes cluster. So if I say kubectl version, I can see that I have a Kubernetes cluster version 1.18. You have at your beck and call a Helm, which is a package manager or Kubernetes to install things. And you also have a dashboard. We could get to the dashboard, but for this talk, I'm not going to get into the Kubernetes dashboard, but the dashboard's running for us right now. In fact, you can say something like, just because it's your first time in, you can say something like kubectl get nodes. Oops, sorry, spell it right. Kubectl get nodes. And we have a 2-node cluster. Okay, it's not a production cluster. This is an experimental sandbox. But it's a little bit more than Minikube. Minikube is a single node cluster. So we have a control plane, a master node, and we have a worker node, node 01. We also have kubectl get namespaces. Standard namespaces we get with normal Kubernetes clusters. And we also have the control plane. Sorry, I went to caps. So kubectl get pods in all namespaces. So in the kube system namespace, we have the control plane components for Kubernetes, the controller, the scheduler, the flannel network, and the kube proxy, and the DNS, and etcd, and our dashboard. So those are all the control plane components of Kubernetes. We don't have anything in the kubectl get pods. We don't have anything in the default namespace. Nothing's running yet. All right. So let's do that. Now we have a clean Kubernetes cluster we can experiment with. Literally experiment with. We're going to do a chaos experiment. The first thing I want to do, just quickly, and I don't want to spend too much time on it, but I need a private container registry because I'm going to be writing we're going to write a Python code, and we're going to build that container, and run that container on Kubernetes. In order to build that container and run on Kubernetes, I need to pull it from a registry. I need to build it, push it into a registry, and then have Kubernetes pull it from a registry. This step number 2 does that exercise of, let me find a container registry. So and there's a Helm chart out there that will install a very lightweight, rudimentary Docker registry for us. So in a moment, it's taking a little time. It shouldn't take that much time. Sorry. So we're just adding to Helm a repo. Yeah, come on. I'm tempted to start another Katacoda scenario because this one's kind of running slow. Sometimes I get a bum. It's free, you know. Sometimes you get a bum server and it's a little slow. Oh, bear with me. Maybe this one's going to be a little faster. You can kind of tell by the ping pong ball in the beginning. See, it's still stuck on that. That should just take a few seconds to run. It shouldn't take that long. So I know that I have a problem with this cluster. And this one is taking a little while to start too. The demo gods don't like me today. So let me start a third one. And we'll see if we have better luck with the third one. 3 times a charm, they say. This one looks a little bit better. I'm going to kill that one. And sorry, this one. See, it's still stuck in Helm repo. I'm having a little problem here with the performance of Katacoda. That's my problem. Sorry about that. Let's see. Okay, so this scenario is up and running. And it was fairly quick. So let me go back over the container registry, do the Helm repo add, and now, okay. So it is a little bit faster. So we're going to install, now that we have the Helm repo where the chart is, we're going to install the container registry. This has nothing to do with Chaos. We just need a registry for us to push and pull our containers from. So in a moment, that registry will return an empty catalog. And indeed, so now we have a Kubernetes, we have a container registry running on Kubernetes. It's actually in the kube system namespace. So if we say kubectl get pods in the namespace, we have in there the Docker registry that's up and running. There's no UI for it, but we can certainly push and pull from it. All right, that's just that step. Now let's get into installing. In order to run Chaos against an application, we need to install that application first. So we're going to install a very simple application. What this is it's a random logger. This fellow by the name of Vincent Zepeda created a very simple Docker container that runs in a loop, and it generates random log messages, info, error, warning, over and over again. So that's all that's doing. And we started, we're going to start 10 of them. And indeed, in a moment, all 10 will be running. Okay, so those are starting up, and they'll be running in a few seconds. So now what we're going to do is we're going to do, I call it the Snowflake Melter. We're going to melt some pods and play a little Chaos. So we're going to use a Python just as an arbitrary language to do it. And the Python's going to go against the Kubernetes API. So here's some example code of what that Python could look like. Again, this is my experiment that I just dreamed up, and it's a pod killer. So at the top of my Python code, I want to import the Kubernetes API. I want to make a connect. I want my pod that's running Python that has a Kubernetes access to the Kubernetes API inside of it. I want it to get the context of where Kubernetes is. And when you run a pod inside the cluster, you can call that command. It's called config.load in cluster config. Now you have a client, and you can say core v1 API. That line, those 2 lines right there, connect to the Kubernetes API and provide an object that you can interact with it. So that we now have an object called v1. So you can say v1, which is basically, hey, Kubernetes, please list the namespaces. Remember in the beginning I said kubectl get namespaces? There's my namespaces. So I can now say, okay, let me go through all the namespaces. Let me do a for loop and say for any namespace that has the annotation on it, chaos equals yes, I want to know about that namespace. And I want to get all the pods in that namespace. So that's my blast radius. I'm saying for only the namespaces that have an annotation of chaos, only those pods I want to delete. I don't want to delete all the pods in kube system because that's where my control plane is running. And I'm not going to play chaos on my Kubernetes cluster. I'm just going to do it on my experiment area. And once I get a list of those pods, I then going to figure out some random number of pods I want to delete. And then I'm going to actually, once I have a list of n number of pods, I have a sub list of pods that I actually want to delete, some random list, I'm going to delete them on a periodic basis. So that's my Python code. And obviously Chaos Mesh has similar type of code inside of it, but much more complex. This is a little more of an example of Hello World. Okay, you get the idea? So let's take that code, and we have a Docker file for you. I'm not going to show you the Docker file because I don't want to spend time on that. But there's a Docker file that will take that Python code and put it in a container. And we have a container registry. So we're going to say Docker build and then push it. And then we're going to build it for that container registry, which is at that location. And then we're going to, once we build the container image, we're going to push that container image in the next command to that registry. Ignore the red. It's coming. In a moment. I hope I can go a little bit longer than, because we haven't gotten the Chaos Mesh yet. I hope we can go a little bit longer than, because I'm coming up on the hour mark here. But we're probably going to go about a quarter after or something like that. I'm going a little long here. Sorry about that. Okay, almost done. And now we're going to take that container, a Python container, and we're going to, container image, I should say. We're going to push that container image to the registry that's running on Kubernetes. It should be just done in just a moment or two. And then we can curl against the registry. Once this is done, we can curl the registry, just prove to ourselves that indeed we've built a container and now it's listed in the registry. So now we're going to start. So this container, we're going to start on Kubernetes and we're going to run it as a job, as a cron job. So at the top of every minute, this Python code is going to run. So once a minute, it's going to look, it's going to run through those loops I just showed you, and it's going to run its chaos. That's one way of doing it, to run it as a cron job. So I just deployed it to Kubernetes. I told Kubernetes, please start that container. Inside of that, and here's the image name. And if we look at cron jobs right now, indeed, we have a cron job that's scheduled to be at the once a minute, about 12 seconds ago. Okay. And if we look at the pods, we'll see that there's here's a pod. So the minute had just came around, and now there's a pod that's running that's executing that Python code. But that Python code is not going to do anything because we don't have anything marked. Remember, it has to be chaos equals yes. We haven't labeled a namespace chaos equals yes yet. So this chaos is just running, but there's nothing to do. So let's give it something to do in the next step. So by the way, you can just kind of look at, you do a stern on the Snowflake Melter, and you can see the output of it. And it is outputting saying, hey, no eligible pods found to with the annotation chaos yes. So let's stop that, and we're going to go over to the target chaos. So we're going to annotate all of those pods, kubectl get pods in the random logger pods that we started are in the namespace learning space. So we're going to annotate the namespace learning space equals yes, chaos equals yes. So then we're going to describe what that namespace is. Indeed, we have a namespace and it has the chaos equals yes. And we have pods in there. So the chaos melter are running pods. So now if we look at the pods in the learning namespace, the random logger pods, see how they're all running right now? And they all been running for about 6 minutes and 20 seconds or so. In a moment, at the top of the minute, remember that chaos is going to be, that Python code is going to run. And it's going to find this namespace with these pods in it, and it's going to kill some random number of them. And indeed, that's just what happened. So it found 3 of them. So it decided, I'm going to kill 3 pods. So it's terminating 3, and 3 got started very quickly. So right there, within about, I don't know, 10, 15 minutes, you went from 0 code, just blank cluster, to writing some code. Okay, code takes a little bit longer to write, but you were able to deploy that to Kubernetes. And there's your experiment. So you can actually create experiments very quickly and run them in Kubernetes without getting into all these fancy open source projects like Chaos Mesh or Litmus or Chaos Cube or all the others that are projects. But would you do this? No, I would probably, I would stand on the shoulders of these giants that are doing these open source projects that have thought about how to design these experiments and make it really easy for me. So how easy could it be if I use Chaos Mesh? Let's get on to that scenario. So so this is the end of this scenario. Let's go back and go to, back to the courses under Chaos and go right to the money. We're going to go right to the money demonstration, which is Chaos Mesh. We're not going to have time, but I would encourage you to also run the Litmus one and experiment with Litmus and see how it works. But we're going to do Chaos Mesh because this is a Chaos Mesh meetup. So there's Chaos Mesh and a little description about it. And again, we just have a blank Kubernetes cluster, and it's fast. It's good. And it's the same as before. There's Helm installed. And we can actually get to the dashboard if you wanted to. I'll let you do that by yourself and follow those instructions. So the Chaos Mesh is designed the correct way. It's designed as an operator following the Kubernetes operator pattern, which is a whole another talk that I do and talk about the operator pattern. But for right now, what we're going to do is we're going to create a namespace in Kubernetes called Chaos Mesh. That's kind of the preferred place to put it. And then we're going to add to Helm a repo where the Chaos Mesh chart is. Now, what this is installing is not Chaos Mesh itself. It's installing an operator that will manage a Chaos Mesh. So that's what the operator is doing. So we're going to curl the so this is, these are the CRDs. And basically we're going to pull from the Chaos Mesh organization the CRD YAML file and then create and we're going to send that YAML file to Kubernetes. So we're pulling it from a remote source and we're sending that to Kubernetes with that command. Now, with Helm charts nowadays, you can build the CRDs inside the chart. That's the preferred way of doing it now. This is kind of like the old way of doing it, but I'm sure the projects can evolve, and so you don't have to have this extra step here. Normally, what you should just do is when you install an operator, you can just install it from a chart. And that's what this next line is doing. This is installing the Chaos Mesh operator. I'm sure you have a new version by now. This is version 0.20, which is a few weeks ago. Maybe there's a newer version. I periodically go into these scenarios and I update them. So if you ever find something that's out of date, send me a note. I'll make sure I go in and update the version, retest it, and republish it. Okay. So there's a version 2 that's running. And in fact, if we looked at in the namespace Chaos Mesh, we'd indeed see that all 3 control plane components of the Chaos Mesh are up and running. Those 3 control plane components are the controller manager, the daemon, the Chaos daemon, and the dashboard. We have a nice visual for it as well. And I describe in the Katacoda text what those 3 components are. But basically, the controller manager is the overall manager of the operation of this mesh. There's the Chaos daemon, which is actually doing the work of the experimental work. And then a dashboard, which is a nice visual UI to show you what's going on inside the mesh. All 3 will show you, all things we'll experiment with right now. So now that we have the mesh running, we do have a dashboard, but it's on the wrong port, and the chart doesn't allow us to change the node port, which is another problem. But what we can do is we can just patch the node port and change it from whatever version, whatever port it's on right now. And what I want to do is I just wanted to get rid of port 31111. So I just changed the service. So now I can go against a URL and get to my dashboard for Chaos Mesh that's running in Kubernetes. There it is. There's no experiments yet. It's a blank slate. So let's do something with our Chaos Mesh. Nice menu, by the way, nice UI. So we'll go on to the next step. Though, like I said, there's and I showed you in my slides, there's lots of experiments that you can do in Chaos Mesh, and it's just, this step is just listing out some of those experiments. You can read those at your own time. And the experiment that we're going to do first is we're going to run a web show. It's actually a very nice UI, which shows the latency. So what we're going to do is we're going to install an application, and then we're going to inject a latency into the network traffic. And then this application actually shows in a nice React web UI the latency graph of all the pings that it's doing. So we're going to, let's see, this command just gets the IP of the target of the cluster. So what we're going to do is we're going to just add that to a config map. That way the web application knows what to ping in order to, and then that ping is going to show latency. So what we did, I'm not going to get into the YAML files or Kubernetes YAML files, but we basically just deployed that container that is serving up that web UI, and we have a service in front of it so we can get to the service, and it should be started in just a moment. Yeah, it's up and running already. In fact, now that it's running, we can get to the UI of this application. And the UI, this React app, is showing in the 2.4 millisecond range over time, it's pinging the kube system. I don't know, it says pinging kube system pod. I don't know what pod it's pinging, but kube system is not a pod, it's a namespace, so I'm not quite sure what that title means. But it is pinging the Kubernetes cluster. There's some network traffic that's doing, I believe it's doing REST calls. So ping. And it's showing the performance, and the performance has some variability to it. But no, we're not doing any chaos yet. Let's do the chaos. So we have these custom resource definitions within Chaos Mesh, and this is part of the operator pattern. So what Chaos Mesh did is it installed interesting new resources for us so that we can not you know that Python code that I wrote and I showed you? That's imperative experimentation. I write some code imperatively to make something happen. The experiments that you do with Chaos Mesh and with Litmus and many others through these operators is a declarative way, not imperative, but declarative. So you write YAML files that define the experiment, and there's controllers that actually will look at the experiment parameters in the YAML file and will run those experiments. And that's what's going on with these custom resource definitions. So if you look at one of your experiments, like a delay experiment, it's basically saying, I have a kind called Chaos Network. That's not a Kubernetes kind. That's a extended Chaos Mesh custom resource that's been added to Kubernetes as part of its extensibility pattern. So there's Chaos Mesh, and you have, this is basically saying in the default namespace, anything with a label selector called app web show, I want that application to inject, to experience latency. How much latency? 10 milliseconds. When? Every 30, I want you to have a latency of 10 milliseconds for 30 seconds. And I want you to do that every 60 seconds. So there's your experiment design of latency. Those are the parameters you pass to the Chaos Mesh engine, and it knows how to do latency with these parameters. Very cool, isn't it? So all you have to do as a developer is send that YAML file to Kubernetes. And the Chaos Mesh will say, oh, you've got an experiment. Let me pick up on that. And there's actually a reconciliation loop that the Chaos Mesh controller is doing. And it's picking up that experiment and going, oh, you want to, yeah, so we just applied that experiment right there. And so now if you say, hey, Kubernetes, do you have this new thing in there called a network chaos? And it says, indeed, I do. And in fact, if you looked at the app now, you'll see that, it was marching along in the 3 millisecond place. We had a little blip there on the network. It's for some reason. And we had another blip here. But what's going on right here? See that how that step that went up to 12 milliseconds? Well, what did the experiment say? We want a latency of 10 milliseconds. So it went up from the baseline and went up to 10 milliseconds. And it ran that for 30 seconds. After 30 seconds, the latency was removed. So that's going to go that for about a minute. And what's going to happen after about a minute? 60 seconds. We're going to experience the same 10 millisecond latency for another 30 seconds. So now you have this experiments running. So now you can, if you actually had a real application, from a customer standpoint, you can have customers start hitting your application and start experiencing the application with this built-in latency. And you want to see what the experience is from a user standpoint. This is the hockey stick that you're pushing against that robot. See that? All right. I think I'm out of time here, but I think you get the idea. I want to encourage you to definitely go on to step number 6 in this scenario, and it will do the typical pod removal experiment where you can start up the loggers like we did with the pure logging system, and you can define an experiment that will remove pods. So it's a different one, not network latency, but it's pod chaos. So you tell it for all the pods in the chaos mesh namespace, in the chaos sandbox, with the labels blast here, delete those. So what I do in this thing is I start some pods that are not labeled with blast here and some pods that are labeled blast here. And this experiment every 15 seconds will delete a pod, but only the ones with a label blast here. That's your blast, controlling your blast radius inside your experiment. So what I've done right now for this evening, in the brief amount of time, I've showed you how to do pure chaos and also how to use chaos mesh. And the litmus one is very similar in terms of its experience. And I would encourage you to also switch over to that. I would just want to conclude with my own slide. One thing I want to say is thank you. But first of all, I want to let you know that I'm doing this exact presentation. And I'm also going to be adding to it the consumer-driven contracts as part of an umbrella workshop that talks about different types of testing on Kubernetes. Chaos is one of them. Consumer-driven contracts is another one. Those are two very high-level maturity model types of testing in Kubernetes. So I have this, this is through No Fluff Just Stuff. They have a virtual workshop series, and I'm going to be doing this November 24th. At the end of next month, I'll be doing a chaos on contracts for Kubernetes quality. So I would encourage you to sign up for that workshop at any time. And I would love to see you there. If you do come, just let me know that you attended this one, you went to that one, and I'll be sure to shout out to you. So thank you. And besides shouting out, feel free to connect with me on LinkedIn. Let me move my head a bit. So those are the social media places where you can contact me. So one of the things I've been doing is ignoring your questions. Do you have any questions in the group chat that I can answer for you? Any questions? How are we doing so far? And if you don't want to type it in, you can also turn on your mic and ask that way.
Yeah, thanks, Jonathan. If you have any questions, this is the time for you to ask.
I hope it didn't go too long there.
All right. So, Chenmen and Zhou Chang, do you have any questions for Jonathan? Jonathan, you can also, if you have any questions for Chaos Mesh, you can ask our maintainers here.
I do, indeed. All right.
Yeah.
Let's see. I'm just. Do I see anything in? There's nothing in the chat right now for questions, right?
No.
Okay. My question for you all is, I kind of alluded to it during the presentation, was there's some reinventions of the wheel in Litmus as well as a few of the other projects. What's the coordination between the groups? And you're also part of the CNCF family. What's the overlap? Are there engineers working on both projects? Those kinds of questions. Or that's a difficult question. I don't know.
Yeah, that is, but I am trying to ask this in a high level way. But currently, so far we do not have any overlap between these two projects, but clearly they're similar in some way. But we're trying to each of the projects we're trying to distinguish ourselves from the other. But I think we have a common goal under the CNCF realm to make the Kubernetes ecosystem like more resilient, to provide this testing framework or methodology as a unified standard or way to test.
Right.
And actually, I think currently we are talking about some community collaborations to promote the chaos engineering concepts and practices, especially for the Kubernetes ecosystem and community, which is our common ground here. Yeah, I think in future, definitely I don't see why not, we can, collaborate together.
So here's a thought.
Yeah.
One idea, and I don't know if this has been bashed around yet, but you know how Knative has grown as being the foundational API for doing serverless on Kubernetes. So the idea of Knative is not necessarily the end product of what you would install as being a serverless framework, but it adds the foundational framework so that a company like TriggerMesh can build on top of Knative to do TriggerMesh serverless, or you can build on top of Knative to do OpenFast serverless, right? And the idea is perhaps there's an opportunity to find common ground between these projects and say, maybe there's a Chaos API framework that can be added to Kubernetes, and then each Chaos framework can then distinct themselves from the other frameworks, but still using this common API. See that?
I like to ask Du-Chang or Chenwen to talk something about this, because I'm not in the technology domain.
Oh,
right.
Okay. Yes, I think Chaos API for Kubernetes is a good way for our Chaos platforms. Or I think maybe we can think it. And in my view, I think Litmus and also Chaos Mesh and also other Chaos platform, we also have the uniform target, and also maybe we can I think so I think this is a good way for us to make Chaos and Chaos Mesh more popular for the host Kubernetes.
Right, because it's going to come. People are going to start. I think more and more people are going to start looking at meshing.
Yeah.
Right. Definitely, I think it's a problem. It's worth thinking about for all of us involved in this chaos engineering community in a larger sense. Yeah, right.
I looked at if you look at the serverless frameworks that run in Kubernetes, they were all kind of doing the same thing in terms of reinventing the same wheels. And then eventually somebody said, you know what, there's common ground here. Let's create something. And then what happened was the other serverless frameworks started saying, okay, we're going to refactor our code to adopt this new Knative standard. And I kind of see there's an opportunity here, but I realize it's early but that's exactly what happened in the serverless arena.
I think it's how things go here, because chaos engineering is actually kind of new in the Kubernetes realm, and it's perfect. It's quite normal for for different projects suddenly see the need for it, so they kind of build their own framework. So they open source it, yes. But ultimately, I think they're going towards the common goal or common standard APIs, sort of. Yeah.
Exactly. Good. I also commend the project for also making the choice of ensuring it's a Kubernetes operator and following that pattern, because that shows a level of thought and maturity in their architecture. That's definitely the way to go. So kudos to that. Was one of the things that attracted me to Chaos Mesh. Anything that is doing operators is at this level and this type of idea. That's the right architecture. So that's a good choice.
Yeah, thanks for your comment on that.
I think we maybe do some research and talk to some Kubernetes community, and maybe we can make Chaos API into the Kubernetes. I think it's a very, very good way for make Chaos engineer to enlist more people to know it and can adopt it.
It'd be interesting. Yeah, I hate to see people waste their talents on creating the perfect round wheel.
Yeah,
because there's more to do, as you know.
Right.
Yeah, and it's the same pattern that that the community has learned about, I think, and I think, and there's other, Tecton is another example. So rather than everybody having their own pipeline, domain-specific language and different ways of doing pipeline, so Argo does pipelines. Argo CD does pipelines. What's the other one? Well, certainly Jenkins X has pipelines. So everybody has their own way of doing pipelines. I forget the other one. Drone, it was the other one. So everybody has their own way of doing pipelines, but they're all very similar in terms of reinventing the wheel. And now everybody looked at Tecton and said, you know what? This is a great underlying just framework to do CI/CD pipelines. And so now Jenkins X can run Tecton pipelines. They just embraced it. They're a differentiator from other types of pipelines. So I see this pattern happening all the time in this community. So
Great.
Anyways, I won't harp on that anymore. That's a good question.
Yeah.
Cool.
So, do you have any other questions?
Maybe everybody else knows, but I don't know. What was the spark that said all of you got together at Chaos Mesh and said, you know what? We're going to create an open source project. And we're going to call it Chaos Mesh, and this is what we're going to solve that the others are not. What's your differentiator, and why did it start a year ago?
Yeah, it's Chairman. It's kind of actually a little bit long story.
If it's already documented, just send me the URL. I don't want to repeat yourself. But.
Yeah, just in a nutshell, Chaos Mesh is originated from our own internal testing framework for the TIDB, the distributed database.
Got it.
Yeah. So at that time, actually, we started practicing this chaos engineering very, very early since we started this database project, and we got a lot of chaos experiments, and at that time it's already based on Kubernetes. So it was not very long, until we realized that this could be something bigger, than just a internal testing framework for the TIDB. So if we open source it and trying to making a chaos operator. So other people on other projects could also use it. Maybe, you know, but at that time, chaos engineering is still pretty new. So we open sourced it. So for the differentiator, I think, first of all, as you can see, we started very simple. We just want to try to, because the distributed system like TIDB is very complicated. So we want to, you know, simulate as many and, you know, chaos types of fault types as possible. So
yep.
As you can see, we have the very, very comprehensive fault injection types for chaos mesh. Yes, that's the first differentiator. But actually, I think that's something other projects can also do. But I think we can, first, that's our initial principles of designing it, and to do it, to integrate all these kind of methods gracefully. And then the dashboard, which is very, very friendly for users to orchestrate and observe.
Yes.
Yes.
And it's also because our TDB is a distributed system, and also we have so many required on chaos, such as our chaos and our failure, network failure. So and this time I try my best to find another project to do this, but it is not suitable for distributed system, such as so many failure on our network. So I just want to do it for our project. And then I find we have so many tools, such as we have other tools, TKV, PD, and others also need chaos experiment. So I just attribute chaos engineering to a published project, and to design for the other distributed system, and also last we open source it and publish it for other distributed systems.
Okay. Wow, that's fascinating. Okay, good, excellent. Nice evolution. All happened in a year, less than, well, you know, about a year and a half probably, or something like that. Crazy.
Yeah.
But it's good you're coming from an organization that allows you to do this too. It says a lot about your organization to say, yes, make it open source, and we support you on that. It's great.
Yeah, because also, you know, the company, in the company we have the TiDB and TiKV, they are all open source projects. So open source is kind of our culture here. If we do something, we want to, you know, open source it, you know, open source way. Yes.
Absolutely. That's a good spirit. I love that spirit. That's great. Good.
Yeah.
All right. That's what it's all about. And I love it because it's teaching everybody. You know, there's a big gap in the industry right now. Like, what's chaos? And why would you run that in production? So there's a lot to teach people.
Of course, I definitely agree. No, and also it's something we are trying to you know, to promote this concept and practices to people who never touched this before. Yeah.
Yep. Cool.
Yeah, and so yes, that's why we can, you know, come together to do this. Yeah. And regarding this Katacoda scenarios, is it open source? And also, you know, currently we have 2 scenarios for chaos mesh, right?
Yeah.
Yeah. And do you intend to add more to it?
Yeah.
Is there something, you know, like we can do together to enrich this content? I think it's very good. It's
the Katacoda scenarios are open in terms of anybody can write a Katacoda scenario and be an author.
Right.
When you
Cool.
sign up, you give an email. It's free. You give an email, and then you get an account, and it actually will hook up to your GitHub repository. And when you make changes to GitHub, there's a webhook, and it publishes your scenario. And it's the text on the left-hand side is just text, and there's a way to put that scenario together with it's some YAML files and Markdown files. It's just doing standard Markdown. I can collaborate with you, and I'd be happy to add more scenarios that we've done already and grow with Chaos Mesh. And if you want to collaborate in terms of like writing the drafts for them, I can get them and then also get them over to the O'Reilly side as well. The O'Reilly side, by the way, looks a little bit different, but it's the same idea. Let's see if I can show it to you really quickly.
Yeah. You want to share desktop? Yeah. Yeah.
So this is the O'Reilly side where, you know, if we just search in here, I don't think. Sorry. Yeah, I always spell it wrong. There it is. So I have Cube Invaders, Cube Monkey, and Chaos Cube. But the new ones, Chaos Mesh and Litmus, and the two other ones, they're going to be coming in. It's in the works. They're about 2 or 3 more weeks. So anybody's a subscriber of O'Reilly can get to these. These servers are a little bit faster and a little bit nicer. As you know, when I did it during the demonstration, it was a little bit slow, but on O'Reilly's side, they're fast. So
that's great.
And we can make them both public and private on O'Reilly's side and public side. And I can work with you. If you can provide me like the drafts, almost like the storyboard for it with just the markup, I can certainly run with it and make sure it's all tested and working well in Kubernetes.
That's something, yes, we should consider about. I think
but you can also,
about this.
You could also do it yourself, by the way. It's an open platform. And if you want to just run with it and make your whole suite of Chaos Mesh Katacoda scenarios, go for it. Definitely. I'm doing many other ones, so I don't have the bandwidth to do, 20 just Chaos Mesh. And if you want to expand your repertoire, you can certainly do that. And then I can work with you to help you get those onto the O'Reilly side as well. Okay.
Yeah, great.
But it looks easy, but the maintenance is what's the difficult part. And then it can get complex. That's why you may want to collaborate with me, at least in the beginning. Yeah,
definitely. Yeah, we will definitely talk more about this in the future.
Cool.
Yeah, cool. And I think, we are about half an hour more than we.
Everybody's still here.
Yeah.
20 of you or so. Yeah, it's awesome.
Yeah.
So I hope everybody learned something and it was helpful. I see lots of thanks. So thank you.
Surely. I think even for me, as someone who is not, who does not have a technology background, I think I got most of the sharing here. So really great.
Good. Good. All right,
great.
I hope that resonated with you. Like the video idea and the animation, and the robots. I really want to get that.
Definitely, it's quite impressive. I think while you're talking, I think we talk something in private, like we should definitely learn from how you present the whole thing to make it so interesting and so easy to follow.
Good, thank you, appreciate that. That's what I do. It's closing that gap and helping people understand how these things work. Because a lot of people get wrapped around like, oh, Chaos Mesh, Chaos engineering, it must be hard. Well, okay, it is hard when you get down into it, but the concepts are easy, right? And people should feel like they can approach these things and not get freaked out by them or think that, oh, this is going to take a long time to learn. It doesn't. Pretty easy.
Yeah, I think this lesson is this course is very good for new users to learn in Chaos Mesh, Chaos engineering.
Yes. Okay, thanks, Jonathan. It's pretty late for you. Yeah, and it's really quite a pleasant time, you know, and it's very enjoyable sharing. So everybody, if you're still here, yeah, just you know, I put all the links from Jonathan and the Katacoda links, and also the workshop links if you're interested here. And also, if you still want to know about Chaos Mass, the project and community, I would like to invite you all to join our Slack here and follow us on Twitter to know to learn more about us. And yeah, that's all for this meeting and sharing. Thanks all for attending. Yeah.
One last thing, if I can make a plug, I do online training on O'Reilly. So if anybody's an O'Reilly subscriber, I do a Kubernetes part 1 and part 2 introductory topics, and part 2 are the advanced topics. I talk about the operator pattern. So if you want to know about those, just search on O'Reilly for Kubernetes in 3 weeks. Just search for that on O'Reilly and you will find me. So that's my plug as well. So either at No Fluff Just Stuff or at O'Reilly, you can find me talking about lots of things, cloud native, Kubernetes, and things like that.
Great.
So thank you.
Yeah, that's exciting. A lot of, you know, stuff for us to learn. A lot of different ways to learn. Yes. Nice.
Cool.
Thanks.
All right.
Okay.
Feel free to stay in touch for any questions. And
yeah.
Thank you for your help.
Thank you.
Thank you.
So
okay, cheers.
until next time.
Till next time.
Bye-bye.
Bye-bye.
See you.